So we're going to be continuing with section 2.3 today, and the focus of what we do now with 2.3 is only going to focus on the physics part of it. So it's applications of derivatives. So we're going to review a bunch of stuff that we've touched on the past few sections with 2.3 when we had learned the other sets of notes, and we're now going to sort of put it all together. So the instantaneous rate of change, that is basically the derivative. So you have the short way, f prime of x, or you have the long way using the limit definition. You can always use the shortcut method. You do not need to use the limit definition. A position function, it relates the position to time, and it's represented by s of t. Displacement is the change in position. So you got to take the position at time 2 minus the position at time 1. Average velocity is the change in position over the change in time. Instantaneous velocity is the first derivative of position. Velocity tells the direction of motion. If the position is increasing or moving forward, then the velocity is positive. If the position is decreasing or moving down, then the velocity is negative. Speed is the absolute value of velocity, so whatever you get for velocity, just make it a positive. Acceleration is the rate at which velocity changes. It measures how quickly you pick up or lose speed. So velocity is the first derivative of position, and acceleration is then the first derivative of velocity. So acceleration would then be the second derivative of position. So all vertical motion formulas, or all vertical motion problems, fall within this format right here. So this is the general formula right here. So it says s of t equals 1/2 gt squared plus v naught t plus s naught. So g is the gravitational force, and it depends on what units you're using. If you're using feet, then it's -32. If it's meters, then it's -9.8. So s naught is your initial position. That's the height that you're starting at. And v naught is your initial velocity. Initial velocity. Okay, and so this is all the information that we're going to now be using to do the next set of examples. And the best thing to do is when you read a problem, first identify, okay, what exactly are they asking for? What process or what formula do I need to know in order to get the answer? So it says an object is dropped from a 100-foot building. The position function is s of t equals -16 t squared plus 100. So the position function is given to you. It's asking what is the average velocity during the first 2 seconds. Well, average velocity is the change in position over the change in time. Okay, so it says during the first 2 seconds. So that means we're going from 0 to 2. So change in position means s of 2 minus s of 0, and change in time means 2 minus 0. So we take the position function and we sub in our values. So s of 2 gets us 36, s of 0 gets us -100, or it gets us 100, sorry, over 2, and we get -64 over 2, which is -32 feet per second squared. Okay, so velocity is in feet per second squared, and it's also negative because the object is being dropped or it's going down. So A asks for average velocity, B is asking for what is the regular velocity. So when we say what's the regular velocity, we're talking v of t, and v of t is the first derivative of position. So I'm going to take the position function and take the derivative of it. Okay, and then we're being asked to get the velocity at 2 seconds, so then all I have to do is sub 2 into that equation. You get -64 feet per second. So the velocity, again, it's negative because it's still going down. So now find the acceleration at t equals 2. Well, acceleration, it's either the first derivative of velocity or it's the second derivative of position. So we already found the velocity equation in B, which was -32t. So the acceleration equation, take another derivative, and we end up with -32. So it's a constant. So given that it's a constant, even if I'm evaluating at 2, it's not going to change. And the units for acceleration are feet per second squared for that. And then it says, when does the object change direction? So when something changes direction, that means that your velocity or your motion movement is 0. So you take your velocity equation, which is negative 32t, and set that equal to 0, and that means that at time 0 seconds, that is when the velocity is going to change, because you walk something up to a building and now you're dropping it down. That's the only time that the direction of motion is going to change for that. All right, let's try another one here. So it says dynamite propels a heavy rock straight up at a position of s of t equals 160t minus negative or minus 16t squared. How high does the rock go? Well, at that highest most point, we know that the velocity is going to change. Okay, so we know that v of t is going to be 0 at that top point. V of t we know is the first derivative of position. So we get 160 minus 32t, and we set that equal to 0. So we get 160 equals 32t, so t comes out to being 5. So it takes 5 seconds for that rock to get up to the highest most point. And then how high? We're talking position here, so we are finding s of 5. So we take that 5, and everywhere we see a t in the equation, we're subbing it in, and it gets up to 400 feet for the position after 5 seconds. Now for B, it says, when does the rock hit the ground? Well, when the rock hits the ground, that means position is equal to 0. So we're going to take the position function, set that equal to 0. We're lucky because they have a 16t in common, so I'm going to take out that GCF with a 10 minus t left over, and we end up with 2 times. We get 0 seconds, and we get 10 seconds, and you leave it, because 2 seconds, you can have 2 different times for that. Now acceleration is the first derivative of velocity again, or it's the second derivative of position. So in A, we had figured out the velocity equation. So the velocity equation was 160 minus 32t. So the acceleration is then going to be negative 32. And again, it's a constant, so we don't have to worry about anything, and it's feet per second squared for that one. Okay? Now, some of you might be saying, well, how do I know it's feet? Seconds is obvious because it always is seconds. But in terms of feet, you go back to the original equation. Remember, all vertical motion formulas follow this format. 1/2 gt squared plus v naught plus s naught. Okay? If when you do 1/2 g, you're ending up with negative 16 right here, that means that g had to be negative 32. And negative 32 is only associated with feet per second. Okay? So just make sure that if that's a negative 16t squared, then you know that the units are going to be feet if they're not given to you. Last part here. It says, what is the velocity and the speed of the object when it is 256 feet above the ground on the way up and on the way down? So first thing, let's use the 256. So that means our position is 256. So we're going to take our position function that was given to us, and we're going to set it equal to 256. Okay, now I'm going to get everything to the same side. I have a preference where I like my t squared value to be positive, so I'm going to move everything to the right. All right, and now we are trying to solve this, so if I move everything, that means I have a 0 left on one side. So they still have a 16 in common, so I'm going to take that out. And then I'm going to keep factoring. So that's a trinomial. And when I solve, I get 2 times. Okay, which makes sense, because if something's being propelled up, it's going to go up, and then it has to come down. And if we're saying that we're looking for where the height is going to be 256, well, again, that would make sense, because we need to know on the way up, it's going to be the lower of the times, and on the way down, it's going to be the latter of the 2. All right, so it says, what is the velocity? So first thing we had to figure out is, okay, well, how long, or what was the time that it took to get there? So now what we need is our velocity equation. So velocity is the first derivative of position. So I'm going to take the equation that was given to us and take the derivative of it. And now what I'm going to do is I'm going to figure out the velocity at 2 seconds. Plug that in. And it's positive 96 feet per second. Okay, and it's positive because it's going up. And then I'm going to do v of 8, same equation. 160 minus 32 times 8.